at some of the methods and techniques used in integration. Now, in our last lesson, we have seen how to integrate a function, a polynomial. That means a function consists of several terms. So this function, they have three terms. So we have seen how to integrate them one by one. But not all the integration that they ask us is like this. They line up nicely one by one. So some of the questions that they're going to ask us is in this form. Like we have two brackets, maybe we have a perfect square, maybe we have a quotient of two functions, and a quotient of two functions like this. So whenever you see bracket like this, bracket, or you see the line like that, showing the division line, you cannot use the method that we have learned in the last lesson. That is, we integrate them one by one. We cannot. So how are we going to integrate these integrals? Okay, how to integrate these integrals? Okay, so let's take the first example where we have two brackets. So the first thing you need to do is to expand the bracket. To expand the bracket, you have to multiply out all this. So when you multiply out all these terms, okay, 2x square, then this one is 3x, then minus 2. So finally, we have something like what we did the last lesson, that the terms, they line up like that one by one. But in the process of simplifying like this, we have not integrated the function yet. So the integration sign is still there. The integration sign is still there. Okay, what we did just now, we just expand the bracket. Okay, so now we are going to integrate one by one. 2x square become, integrate the index increase by 1, so become cube, then you have to divide by 3. This one, x become x square, then you divide by 2. Integrate a constant, this one is the very famous one. Okay, integrate a number, you get the number multiplied by x. Okay, so this is what we get. 2x cubed over 3, 3x squared over 2, and 2 become 2x. Since this is indefinite integral, you have a c behind. Okay, and you want to simplify further, you can write like this. Okay, either you write like this or like this. It doesn't matter this one. Okay, any questions so far?
No, teacher.
No. No, then we carry on with the second type. Now this second type of integral, there is a square there, right? Now for differentiation, we have the product rule to take care of this square, cube, and so on. But in integration, there is no chain rule. So we have to expand. So how to expand this? Okay, so we have a square is x squared, 2ab, 2 times x times 1 over x. X times 1 over x, they cancel off. So you're left with 2. Then b square, the last term here square. 1 square is 1. X, you square it, it become x squared. Well, we have not integrated the function yet. So what we have done here is we just expand, no integration. So no integration, the integration sign is still there, right? Okay, so now you can integrate. Integrate x squared becomes x to the power of 3 divided by 3. Integrate 2 is a number, so it becomes 2x. Now this one is 1 over x squared. is x to the power of -2. You use your imagination, right? You use your imagination, x to the power -2. -2 plus 1. How much is -2 plus 1?
-1.
Correct. So it will become x to the power of -1 divided by -1. Let's see, is this correct? Yes, it is. So x cubed over 3, this one is 2x. This is x power -1 divided by -1. So this one you have to simplify further because the -1 is at the bottom. So simplify further, 1/3 x cubed, 2x minus the negative put in front become minus negative x above -1 is 1 over x, then plus c. Okay, any question?
No, teacher.
No. So far what we have dealt with is expand the bracket. We have bracket there, then we expand the bracket. Oh, the next two type of question is not multiplication anymore. It is division. Okay, it is division. So how to divide this? You divide them term by term, like what we did in differentiation. So we separate them out, 3x cubed over 3x, 2x squared over 3x, 5x over 3x. So it becomes something like this. Okay, becomes something like this. Have to simplify some more. Okay, x cubed divided by x, x squared. X squared divided by x, x. X divided by x, no more x. So far, what we have been doing is just simplify the function. From this step to this step, we break them up. From this step to this step, we divide them one by one. So far, we have not done the integration yet. So no integration, the integration sign is still there. The integration sign is still there. Okay. So finally, now you can integrate. Integrate x squared, x cubed over 3. Integrate x. X is x to the power 1. X squared divided by 2. Integrate a number, 5x. Let's see if it is like that. Yes, correct. X cubed over 3. Right. Then this one, the number in front, you don't do anything. This number in front. So you copy back here. You copy back here. The x becomes x squared over 2. 5 over 3 becomes 5 over 3 x. 5 over 3x. And this is indefinite integral. You have to put a c there. You have to put a c there. Right? Okay, so simplifying, you have 1/3 x cubed. The 2 and 2 cancel. 1/3 x squared. And the rest remain the same. Okay, any questions so far?
No, teacher.
No. Oh, the difference between example 3 and example 4, example 3 has only one term like this at the bottom. Example 4, you have 2 terms at the bottom. So the way you do this question and the way you do this example 4 is different. This one, you just break them up one by one. This is a factor. X plus 1 is a factor. So we try to factorize the top. Try to factorize the top and cancel away the factor at the denominator. Then you can integrate. So always you see something at the denominator there, denominator, you cannot integrate. So you try a way to get rid of the denominator. Here is by dividing each term with x. Here you have to cancel away the term. In order to cancel away this term, you have to factorize the top. So how to factorize the top? First of all, you cannot see. So you have to take out the common factor 3 first. Take out the common factor 3. Still, you have not factorized this function yet. Okay, so you factorize it. It becomes x plus 1, x minus 1. Now you can see that the common factor is x plus 1. And these two factors, they can cancel away. Right. Now, so far, these two steps, you still have not integrated yet. So the integration sign is still there. So now we cancel the term and see what. So when you cancel away the x plus 1, you are left with x minus 1. So the 3 and the x minus 1 is still there. Now this 3 is a number. You can always take out. Don't integrate the number. You just leave it aside. Okay? So you take out the 3 like this. Okay? This is one of the technique we can do. Because the 3 is common for both of them. So you take out the 3. After you integrate, you multiply back the 3. Okay? So now you just take out the 3 first. Even then, you have not integrated the function yet. So this one is quite simple. Integrate x, x squared over 2. Integrate negative 1, negative x. Let's see. Okay. So integrate x, become x squared over 2. Integrate negative 1, become x. And you have plus c behind. Okay. The 3 is just outside this. So now you can multiply the 3 inside. Multiply the 3 inside. 3 over 2x squared. Multiply the 3 inside. 3x plus c. Any question?